Imagine building a factory so precise that a single speck of dust, invisible to the human eye, can destroy a product worth thousands of dollars. Now imagine that factory needs air cleaner than a hospital operating room, machines costing hundreds of millions of dollars each, and so much ultra-pure water and electricity that it rivals the consumption of an entire small city. Workers have to wear full-body suits just to walk through the building, and a single power flicker lasting less than a second can destroy months of production. This isn't science fiction. This is a normal day at a modern semiconductor factory, and the bill behind it will change how you think about the chip inside your phone. Most people look at a microchip and see a small piece of silicon, maybe the size of a fingernail, and have no real sense of what it took to actually manufacture it. The truth is that modern semiconductor fabrication is quite possibly the most precise, most environmentally sensitive manufacturing process humans have ever developed, operating at a scale of precision, measured in nanometers, distances so small that the width of a human hair is roughly 10,000 times larger than the individual features being carved into these chips. Achieving that level of precision requires an operating environment so controlled and so expensive to maintain that it makes almost every other industrial facility on Earth look comparatively simple. Let's start with the clean room, because this is the foundational requirement that everything else in the facility is built around. A semiconductor fabrication plant, known in the industry as a fab, operates its production floor as an ultra-clean environment specifically engineered to remove airborne particles that would otherwise contaminate the manufacturing process. These clean rooms are classified by the maximum number of particles allowed per cubic meter of air, and the most advanced modern fabs operate environments dramatically cleaner than a hospital surgical suite, filtering out particles smaller than what the human eye can even perceive. Achieving and maintaining this level of air purity requires massive, continuously running filtration systems, and building this infrastructure alone, before any manufacturing equipment gets installed, can cost hundreds of millions of dollars for a single facility. Here's the detail that surprises people. This air filtration system isn't something you install once and forget about. It has to run continuously, 24 hours a day, every single day the fab operates, because the moment air filtration stops or degrades even slightly, contamination risk increases immediately, threatening the entire production process. Workers inside these facilities wear full-body protective suits, commonly called bunny suits, specifically designed to prevent human skin cells, hair, and clothing fibers, the everyday particles people shed constantly without noticing, from ever entering the manufacturing environment. Even breathing patterns and movement speed inside a clean room are carefully controlled, because rapid movement can disturb airflow patterns in ways that increase contamination risk. Now let's talk about the manufacturing equipment itself, because this is where the numbers become genuinely difficult to comprehend. The machines used to actually pattern circuits onto silicon wafers, called lithography systems, represent some of the most sophisticated and expensive pieces of manufacturing equipment ever built. The most advanced lithography machines currently in use, capable of achieving the extreme precision required for cutting-edge chip manufacturing, use a technology called extreme ultraviolet lithography, and a single one of these machines can cost well over $150 million. A modern advanced fab doesn't operate just one of these machines. It typically operates dozens of pieces of specialized equipment across the full manufacturing process, meaning the total capital investment in equipment alone for a single state-of-the-art fab can easily exceed $10 billion before the facility produces a single functional chip. Let's talk about why these machines are so expensive, because the engineering involved is genuinely extraordinary. Extreme ultraviolet lithography systems work by generating a specific wavelength of light so short that it can only be produced through an incredibly precise process involving vaporizing microscopic droplets of tin using a laser tens of thousands of times per second, then using an elaborate system of mirrors, themselves polished to a level of smoothness measured in atoms, to focus that light with enough precision to etch features onto silicon wafers at nanometer scale. Only a small number of companies in the entire world possess the engineering capability to manufacture these machines, which means fabs seeking to purchase this equipment often face significant wait times, sometimes years, simply due to limited production capacity for the machines themselves. Let's talk about water, because this is a resource requirement most people never consider when thinking about chip manufacturing. Semiconductor fabrication requires enormous quantities of ultra-pure water, water that's been filtered and purified to a standard far exceeding drinking water quality, used throughout the manufacturing process to rinse silicon wafers between processing steps. A large modern fab can consume millions of gallons of ultra-pure water every single day, and producing water at this purity level requires its own dedicated, expensive filtration and treatment infrastructure operating continuously alongside the manufacturing process itself. In regions experiencing water scarcity, this consumption has become an increasingly significant operational and political consideration, with some fabs investing heavily in water recycling systems, specifically to reduce their draw on local water supplies. Let's talk about electricity, because running this level of precision manufacturing equipment alongside the continuous air filtration and water purification systems requires an enormous and, critically, an extremely stable power supply. Modern advanced fabs can consume electricity on a scale comparable to a small city, and unlike many industrial processes, semiconductor manufacturing is extraordinarily sensitive to even momentary power fluctuations. A power interruption lasting less than a second, something most people would never even notice in their own homes, can be catastrophic inside a fab, potentially destroying wafers mid-process and costing months of accumulated production value in a single instant. To prevent this, fabs invest heavily in redundant power infrastructure, backup generation systems, and sophisticated power conditioning equipment specifically designed to ensure that the facility's electrical supply never experiences the kind of fluctuation that could compromise an in-progress manufacturing run. If you're fascinated by what it actually takes to manufacture the technology inside nearly everything we use, hit subscribe, because every week we break down the hidden operational reality behind the world's most extreme and precise industrial systems. Let's talk about yield, because this is the metric that ultimately determines whether all of this enormous investment actually generates a return. Not every chip produced during a manufacturing run turns out functional. Microscopic defects, contamination, or process variations can render individual chips unusable, and the percentage of chips that come out of a production run actually meeting quality standards is called the yield. For cutting-edge manufacturing processes, especially when a fab is first bringing a new generation of chip technology online, yields can start out surprisingly low, sometimes with a significant percentage of initial production runs failing quality standards entirely. Improving yield over time requires constant process refinement, extensive data analysis, and ongoing engineering investment, because even small improvements in yield percentage translate into enormous financial impact when spread across millions of chips being produced. Let's talk about the workforce required to run a facility this complex, because this isn't a lightly staffed operation. A modern fab employs thousands of specialized engineers and technicians, many holding advanced degrees in materials science, electrical engineering, and chemistry, because operating equipment at this level of precision requires genuinely deep technical expertise across dozens of specialized manufacturing steps. This specialized workforce commands significant salaries, and the intense global competition for semiconductor engineering talent has made staffing one of the ongoing operational challenges facing the entire industry, particularly as multiple countries have begun heavily investing in expanding their own domestic semiconductor manufacturing capacity simultaneously. Let's put a full year together, because that's where the real financial scale of this industry becomes clear. Between continuous electricity consumption rivaling a small city, massive ultra-pure water treatment and consumption, ongoing equipment maintenance for machines that individually cost hundreds of millions of dollars, ongoing process engineering investment to maintain and improve manufacturing yield, and salaries for a highly specialized workforce numbering in the thousands, the annual operating cost for a single advanced semiconductor fab can run into the billions of dollars, entirely separate from the initial tens of billions of dollars, often required just to construct the facility and install its manufacturing equipment in the first place. So why does anyone build facilities this expensive and this operationally demanding? Because semiconductors have become the foundational technology underlying essentially every modern electronic device, from smartphones and computers to automobiles and medical equipment. and the ability to manufacture cutting-edge chips domestically has become a matter of genuine strategic and economic importance for major economies worldwide. Countries and companies are willing to fund investments of this scale because falling behind in semiconductor manufacturing capability increasingly means falling behind across the entire technology sector, an outcome most major economies consider far more costly in the long run than the enormous ongoing expense of actually building and operating these facilities. So the next time you look at the chip inside your phone or computer, remember what it actually took to manufacture that small piece of silicon. You're looking at the result of a facility with air cleaner than a hospital operating room, machines individually worth hundreds of millions of dollars, using light generated by vaporized tin droplets, millions of gallons of ultra-pure water consumed daily, and a power supply engineered so precisely that even a fraction of a second of instability could destroy months of accumulated production. The chip is tiny. The factory behind it is one of the most extreme environments humans have ever built. Disclaimer: this content is for educational and entertainment purposes only. Operational costs are estimates based on available data.